Okay, this is section 1.1c. By the end of this section, you should understand the meaning of linear expression and linear equation. You should be able to solve multi-step linear equations with rational number coefficients, including equations whose solutions require expanding, distributive property, and collecting like terms. And you should be able to write and simplify linear expressions that model real-world situations. Okay, we're going to kind of skip around. So, what I want you to do is go to the bottom of page 23. And we're going to, before we do that, I want you to find somewhere in your notes to write a to-do list. Okay, so these are multi-step equations, and you're going to need to do a couple things in order to solve them. So let's start with our to-do list. It's going to get longer as we progress. So the first thing you want to do is collect like terms on one side. Oops. Then you want to undo any addition or subtraction, and then you want to undo any multiplication or division. Got to do them in that order. Okay, so let's look at number 3 on page 22 down to number 3. And let's go through our to-do list. So the first thing we need to do in order to solve or find x is to select the like terms. Squeeze this down to the smallest possible thing. So let me get a different color ink here. And I'm going to rewrite this so it's not with a dark background. And I'm going to collect these. That means add them together. We're going to add them together and keep them on the same side. So 4x and 3x is 7x minus 1 equals 6. Now the next step is to undo any addition and subtraction. And when you undo it, you use something called the inverse operation, which is the opposite. So instead of subtracting 1 from each side, I'm going to add 1 to each side. That way it's canceled from the left side, and we're closer to having x alone, and then it's added to the right side. So now I have 7x equals 6 plus 1, or 7. I'm going to undo, this is multiplication, by the inverse, which is dividing. So I'm going to divide each side by 7. So I have x equals 1. Number 4. Lots of you get thrown when the x's are on the right side. Treat it the same way. So I have 10 equals negative x plus 3x plus 4. So we're going to do our first step on our to-do list, and that's to collect these like terms. Remember, we're combining. So we have a negative x and positive 3x's. So when you add those together, you have positive 2x plus 4. Now our next step is to undo addition and subtraction. This says add, so we're going to use the inverse operation and subtract 4 from each side. So I have 6 equals 10x. We have to undo this multiplication here. So now I'm going to divide each side by 2. So now I have x is 3. Okay? Remember, when you're collecting, you're not using the inverse operation. Only when you're collecting like terms on the same side of that equal sign. If you cross the equal sign, then that's when you have to use the inverse operation. All right, let's move on to 5. Number 5. So here we are going to collect like terms on one side, add those together. So I have 2x and minus 1x is x. Now I'm going to undo this addition by subtracting 4 from both sides. So I have x equals 4. Now number 6. Copy that down. A few more terms to deal with here than before. A little more collecting to do. So we have to collect our x's together, but we also have to combine these constants here. Okay, so let's deal with the x's first. So negative 2x and positive 4x gives me 2x. And when I add negative 3 and 5 together, that's positive 2. Our next step is to undo this addition by subtracting 2 from each side. So I have 8 equals 2x. Now I'm going to undo this multiplication with the inverse, which is division. So I have 8 divided by 2 is 4. They like the answer 4. Okay, moving on. Let's skip number 7. We're not going to work with the tiles right now. Let's go to number 8. It's on the bottom of page 23, I believe. Okay, so we're going to follow the same steps. We're going to see if we can collect like terms on one side. So we have our negative 7 and 5x together, which will give me negative 2x plus 3 equals negative 9. I'm going to undo this addition by subtracting 3 from both sides. And negative 9 plus negative 3 is negative 12. Be careful with the signs here. So now I'm going to undo this multiplication, and I'm going to divide by negative 2. So negative 12 divided by negative 2 is 6. Number 9. So I have 17 equals m plus 5 minus 3m. We're going to collect those like terms over here. So negative 3m and a positive m gives me negative 2m. We're going to undo this. Even though there's not a sign, we know it's positive. We're going to undo this addition by subtracting. A little tricky. There's no sign there, so you know it's positive. So you have to do the opposite. So this is 12 equals negative 2m. We're going to divide each side by negative 2 to undo this multiplication. So 12 divided by negative 2 is negative 6. That's your sign. Number 10. So we have decimal. That's a half. So we have 5/10 or half b plus 2b. So we have, 2.5b when we combine them. And now we're going to divide by 2.5. You can leave it as a decimal. You can use it as a fraction. Doesn't matter. Remember though, you want to keep that negative sign. Don't forget about it. There's a lot going on here. So you're going to take 50 and you're going to divide, or negative 50 by 2.5. It's negative. Oh, sorry. So b equals 20, and it's negative 20. Okay, oh, here we have fractions. We all love fractions, and luckily they have the same denominator. So let's rewrite this. Careful with the signs again. Okay, so first, we don't have to collect any like terms, which is nice. So I'm going to add this 4/3 to each side. So I have negative 2/3 plus 4/3. Make it a little easier, I have negative 2 plus 4 over 3, which will give me positive 2/3. So I have 6r left over here. Now we have to undo this by dividing by 6. So if you divide, you multiply by the reciprocal. So 2/3 divided by 6/1 is the same thing as 2/3 times 1/6. When you cancel, you end up with R equals 1/9. All right, that was number 11. Moving on. Number 12, Ricardo solved the following equation incorrectly. Circle the mistake and describe the mistake in words. Then solve it. Okay, so let's see what he did. Let's see what you should have done. So you have this and this and this. And when you combine them, you have 2, 3, and 8. There's his mistake. He forgot this. He forgot to combine this in. So this should be 8x equals 56. And when you divide by 8, x is 7. All right, now we're on 13, word problems. It said Carson and his family drove to Disneyland. They started driving on Thursday, then stopped for the night. On Friday, they drove twice as many miles as they had on Thursday. On Saturday, they drove 50 miles more than they had on Friday. Carson's mom asked him to write an equation to determine how many miles they drove that day. He wrote the following equation. So under A, let's match the expression with what it represents. So what's M? Well, M is the number of miles they drove on that very first night. Right there. 2M is the amount of money or amount of miles they drove on Friday, twice as many as they did on Thursday. 2M plus 50, which is right here, is the miles they drove on Saturday. And this is the total miles they drove. So if Carson and his family lived 650 miles from Disneyland, how many miles did they drive in each day? So, M is the number of miles. Let's figure out what M is first. So we're going to take M plus 2M plus 2M plus 50 equals 650. We're going to combine all these M's. So I have 2 and 1 more is 5M plus 50 equals 650. I'm going to subtract that 50. So I have 5M equals 600. When we find out what M is, we can plug that number in and then figure out what they're driving each day. So when we divide 600 by 5, we know on the first day they drove 120 miles. So Thursday is their first day, right? On Thursday, they drove 120 miles. On Friday, they drove twice that. So 120 times 2 is 240. And then on Saturday, here is Saturday right here. We have 240 plus 50 is 290. Okay. George started writing a story that matches the expression and equation shown on the left. Pieces of the story are missing. Help him finish the story and solve the equation. Talon's age is T. Peter's is 8 times Talon's and 3 more. And someone, if you add the 2 up, is 39 years old. So I'm trying to figure out Peter and Talon's age. Peter tells me that he is 3 more than 8 times Talon. Together, Talon and Peter's ages, right here, are 39. How old are Peter and Talon?